Yeah, let's walk through this. And yeah, this is going to be sponsored by KTBYTE Computer Science. And for those who don't know about KTBYTE, it is an after-school program where we teach computer science for kids starting at the age of 8 all the way up to the age of 18. And we'll be talking more about KTBYTE at the end of the seminar if you are interested in learning more. Okay, so our agenda for today. I'll do a quick meet the presenter, as well as entry polls. If you've not done entry polls yet, please do them. Then I'm going to be talking about the different categories of career paths where computer science is useful. I'm talking about the traditional technical ones that most people go into, then still traditional but with less coding, CS adjacent, and then the more non-traditional roles that seem like they're not related to computer science, but coding skills can still be useful. And then at the end, we will wrap up after about 25 to 30 minutes with a question and answer session. This is a good opportunity. If anyone has questions, I can answer them. And we will also ask you guys to do an exit poll. Cool. Alrighty, so a little bit about me. My name is Srijan. I did my undergraduate at UMass Amherst. I'm currently a master's student at Georgia Tech. My degree is computer science, but I did a lot of psychological computer science, sometimes called human factors, human-computer interaction. And that's kind of my background, very heavy research background. I research a lot about where and when technologies fail for different types of users and learning how to make these technologies more accessible, more safe in a user-centered manner. And I worked in places at different universities, RPI, Northeastern, as well as some other companies you may have heard of, like Vanguard and PTC. And now I'm here full-time at KTBYTE. So yeah, I've had some more traditional coding roles at these big companies. And here at KTBYTE, I play more of the product associate role. And I've also done some research roles at the universities. You can find more about me by clicking on ktbyte.com/staff. You can find out about me as well as the other KTBYTE instructors if you wish to do so. Cool. Alrighty. So first, I'm going to be talking about these traditional coding roles. And when I say traditional coding roles, these are very highly technically challenging roles. They require a very high level of technical knowledge. So for those of you who are familiar with our KTBYTE curriculum, this is where you'll see the Core 5B USCO level, high level of programming. And people in these roles, these are very code heavy, meaning there's going to be a lot of code that you're going to be exposed to at one time. And when you're working in these roles, you're often focused on one part of a huge puzzle. So people who are here in these technical roles must really be okay with not always knowing what the big picture is, what they're working on. And I see a few people with questions. Please put your questions in the question and answer form, and we'll get them to the end. Okay, but yeah, people who work here must be okay with not always knowing the big picture, not always knowing the nitty-gritty technical stuff, apart from what they are working on, and they must be at peace with that. But this is one of the highest paying fields, and it is what the majority of computer science graduates do in the long term. These are software engineering, data analysis roles, and hardware engineering, and nearly all computer science try this field at some point. Again, it can range from software development to data science to circuit design to robotics. And these are all pretty different fields, but the theme is that it's very coding heavy. You need to have a very mature understanding of different programming languages, knowing when to use what type of programming language, etc. And then these are the roles with less coding. And these fields, they require coding maturity. Don't get me wrong. You still need to know basic coding, but they don't rely on the highly technical details. Typically, Core 4A knowledge is sufficient for these roles. So think first semester freshman in college or even high school level coding. And the CS adjacent field of human factors, this involves understanding how people use technology and the pain points around development, often using simulations. And this is a field of research that I myself have done a lot. And here are some pictures about my human factors and my UX research experience. So applying this realm of understanding technology with relation to people can be applied toward a variety of scenarios. Up here on the top right, this is actually a driving simulator. Okay, so we created this driving simulator from a sponsor, probably Toyota Research, and they gave us this simulator, and we wanted to study how pedestrians and this autonomous vehicle were interacting with each other at dangerous intersections. Okay, so in order to create this simulator, we needed to know some basic coding because we had to edit what they were giving us. But they gave us the majority of the code, so coding wasn't really the main part of this project. Being able to adapt the code to create a research tool for us to understand how pedestrians interact with this autonomous vehicle, it was the main point of it. Um, Down here on the bottom right, this is a sidewalk robot. So if you're in major cities, maybe you've seen this robot walking around with people. If you're in techie areas like Roosevelt Island or Cambridge, you may have seen these. And here you can see this person walking in front of this robot, and this is the Jita robot. So when this person walks around, this robot's going to follow them. It's a little ball. Okay. You can look up videos, and some of them are amusing. So here, this project, we were focusing on where people are comfortable taking this robot. So again, it's important for me to understand how this robot is built and what are the technical limitations of this robot, which is good for me having a CS maturity, but I wasn't involved in developing this robot. In fact, we bought this robot from a company, and that company did all the engineering around building the robot and coding the robot. But it's still really important for me to understand the technical limitations about what it cannot do with relation to the camera and the hardware. Okay. Let's see. So, and up here is a video. So again, here, again, making another simulator using virtual reality. You can see a little headset here. And these headsets are used a lot in this kind of simulation engineering field, creating a tool for us to ask a question. And this is a video of a virtual reality scene that we had to code onto this virtual reality headset. And as you can tell, we were trying to, as I hope you can tell, we were trying to create some version of an urban setting, but it's not perfect, right? And the reason it's not perfect is that we didn't delve into the highly technical details. We were just trying to create a proof of concept that it's possible to create an urban setting on this virtual reality headset. And that's where having technical maturity is useful to create this proof of concept, but we didn't go so far as into making sure all the limbs are connected and making sure all the buildings are accurate. Okay, so that's virtual reality with respect to creating a pedestrian simulation, and we can also do it with other driving scenarios as well. Over here on the top right, we see like a bicycle simulator that I made from scratch, and we have some cameras. So again, we bought these cameras from a store, and we didn't code these cameras, and we have no idea how the cameras work, but we know that they work. And we can use the data from these cameras to understand bicycle safety and how they react to other objects in the simulation. Okay. And yeah, so I talked about robots, a little bit of simulating, a little bit of virtual reality, but I see a lot of people raising their hand, but I will get to you at the end, I promise. But yeah, but this realm of understanding technology and the user's needs and user pain points can be applied towards mobile applications, websites, etc. And then there's roles with less coding, still that are apart from the simulation engineering. Other field might be UX design. Okay, here we see this design prototyping process. This is called wireframing. It's almost similar to drawing on a computer, drawing the different parts of the website that someone can code later. Okay. And the reason why technical maturity is useful for this is because we don't want someone to draw something on a website that is not possible to code. So being able to design an element on a website or a mobile application and being aware of the technical limitations is really important in a UX design role. Okay. Then on the far right, we have a lot of math. And the reason I have that is because theoretical math is also a CS adjacent field. And when you think of math and computer science, typically at the high school level, we don't really correlate those. But once you get into college and higher level courses, you'll notice that a lot of math and computer science courses are cross-listed. For example, you might use math to prove an algorithm will always be the most efficient or an algorithm will always work. You need those foundational math concepts to prove things in your code. So you need to both understand the coding algorithm part of it, as well as be able to do the computational math side. Okay. And then the last part is the system mapping knowledge, also sort of similar to product management, similar to what I do at KTBYTE right now. And this is understanding different parts of an organization and how they fit together. Okay. Being able to understand the business side, the technical side, as well as the marketing side, being able to fit all these pieces together is a skill that many computer scientists use later on in the career. I'm trying to switch the slide. It's not switching. There we go. Okay. And so I've talked about traditional computer science roles, slightly less traditional computer science roles, and now we have the roles that are seemingly unrelated to computer science. All right. So many of you guys will enter college studying computer science, and many of you will come out with your computer science degree. All right. But in the US, you can switch majors a lot. In some schools, it's really easy. In some schools, it's harder. And in some private schools you can switch your major in a matter of 15 minutes. In public schools it's a lot harder because there's state funding and all. But being able to code in a field in this age is really valuable, especially when a lot of people cannot. As a personal anecdote, when in my freshman year, I knew several biology pre-med students, and the reason they were able to get into research labs early on for biology was because of their coding skills. Being able to analyze data in these types of settings are really important. Okay, so just because and they did computer science in high school. And just because they did computer science in high school and now are studying biology, they didn't forget their computer science skills. They were still useful in a seemingly unrelated field. And this can be applied. I was talking about bio, but this can be applied towards a variety of realms. If you think about journalism, a lot of times journalists will be dealing with a lot of data and they have to be able to visualize and create an image for it. When creating that image, it can be really useful to know how to code, because when you code it, the computer can create an image way faster than you'll be able to by hand. Think about graphing, bar graphs, line graphs, stuff like that. And then even within the medicine part, other than the data analysis, there's also stuff with 3D modeling. Some of you may have heard of computer-aided design or 3D printing. For that type of stuff, coding is really important, being able to picture stuff in a 3D space. And lastly, if you go into supply chain and manufacturing types of environment, being able to improve processes is really important, and machine learning could tie into that as well. And then there's tech support, teaching, which many instructors do at KTBYTE, field engineering, and these possibilities are really endless. And basically in every field, you will find a way to use computer science. All right, so bottom line, computer science is a skill that's useful in a variety of fields. Right now in college, there's a lot of things called general education requirements. And these are requirements that every college student has to take. And right now it's mostly math, English. But it's very likely in the next 10, 15, 20 years, computer science will become a general education requirement. It's going to be counted as general knowledge that everyone who's an adult just has to know. That's why at KTBYTE, we encourage all students to learn code because of its wide applicability. And yeah, you can learn more about KTBYTE classes if you go to ktbyte.com/talk here. Okay. And at the end of this presentation, we can talk more about that if you want, and we'll also give you a QR code. Alrighty, question and answer session. Michal will release the exit poll. And yeah, please do the exit poll on the way out.
Yeah, doing that.
finished a little bit early. Cool. Let's see. Okay, I see one hand. Alex, I'm going to give you permission to talk, okay?
So I must say that that I wondered well I just can we then also use it to actually then also make animation? Like can we actually
Yeah.
find a way to like make like video animation? It's just I'm actually more like a video animation to draw. Like it kind of it's just like drawing and trying to turn it into an animation.
Yeah, so drawing is something that code is used for. We do a little bit actually at KTBYTE in Java processing. Java processing is actually a tool that UX designers will often use to create these visualizations. And those are all very basic animations, and you can build on that as well as you progress in your career.
Okay. Okay. I hope you have a good day.
Cool, you too. George, I'm going to give you permission to talk. All right, go ahead, George.
Is the seminar over?
Yeah, seminar is over. Question and answer session now.
Hi, do you know about the future of the computer science as a career?
Can you say that one more time?
Yeah, right now there's a big challenge for the CS the student with computer science degrees. So how is the future?
Yeah, so I think you're asking about the current, say, the job market for tech. Yeah. So in 2021 and 2022, it was no secret that the job market for computer science was really good. New grads were making 200, 300 grand. Now in 2023, 2024, new grads are not making that. That said, it's still a very lucrative career. And right now the market's just bad for all majors. So I wouldn't use 2023 and 2024 as your basis for that. And as many people will try and scare you and say that AI is going to take over your job, but that won't happen. As long as you're able to use AI in order to do your job better, you will be fine. So yeah, that's what I have to say about that.
Okay, thank you. Thank you.
Sure. Alrighty.
Anyone else has problem? Have any more questions? Okay, so looks like no one else has more questions. So this is our today's seminar. I will end the poll. Thank you, everyone. Okay, so thanks everyone again for coming to today's seminar. So this seminar, we're gonna stop here. Thank you. Bye.